PAE, for inviting me to this talk. And this is a wonderful platform. And actually, I would like also to encourage my students and also my colleagues to join these type of courses. So because this is a platform which from where we can learn, first of all, the free of cost, and also we are having the professional courses. And also this is one of the part of the professional course. So today I will be talking about, actually this is for today workshop. So I will be talking today and tomorrow about prospect maturation. And also we will be adding AI, which is the artificial intelligence for hydrocarbon analysis. As all of you knows that these days, the AI, artificial intelligence or the machine learnings, we are having in all over the field. So as a field of geophysics, or especially if we look at the industry, so we are also focusing on this type of analysis, like why we don't have this like machine learning or the artificial intelligence to predict the hydrocarbon, because this is one of the very high risk business in the world. I mean, the oil and gas is always called the high risk business, and also you have a lot of expenses on that just to find the hydrocarbon. If we add this AI stuff into the hydrocarbon prediction, then I believe that we will having the more accurate drilling points. So this is the agenda for today's talk. So I will be going through about the introduction to the topic. We will be look at what is the prospect maturation and what are the differences. We will start from the very basic, because I know some of you guys are not from the industry and you are from the different field. So we'll start in this workshop from the basic stuff. Then also we'll be looking at the block acquisition and the life of field. So it start from the acquisition to the final stage. Then we'll be looking at the basin evolution, and also we'll be having some introduction to the AVU analysis, which I will highlight in tomorrow session, some part. And we will be looking at the machine learning, how we use the machine learning stuff or AI in prospect maturation. Then obviously, when we having this prospect maturation, the petroleum system play a very essential role. So in prospect maturation, how we find the petroleum system in the area. So what are the component of the petroleum system, that also we are going to look at today workshop. Then we'll be looking at exploration geology, prospect evaluation, and also the exploration well drilling. So that will be the final stuff. So half of the topics will be covered in today, but some of the topics will be covered in tomorrow workshop. As I mentioned, this is actually the 5-day course, which we are going to offer later on after this workshop. So that is the outline of the, the 5-day course. So in day 1, we are looking at the topics like introduction, then we have the prospect maturation and the place, then also looking at the risk, volume, and uncertainty of the specific things which we have in this part. Then also the prospect portfolios, then overview of the machine learning, because we will start from the very basic of the machine learning. Okay, in day 2, we will be looking at the traps and their types, machine learning for prediction. So the first day we'll be having the introduction, then we'll be diving into the prediction, how we use the machine learning for prediction. Then we'll be looking at the traps and also the important hydrocarbon provinces. What are those? Then we'll be diving into the reservoir importance in hydrocarbon provinces as well. Then in day 3, we'll be looking at the seismic attributes, AVU analysis, seal, pressure, overpressure. Then also, I will also cover in the seal, the pressure, and also it's important in hydrocarbon provinces, and how these provinces can be charged from the source rock. In day 4, we have these topics, like in that we'll be having the hands-on. So in that, I will be introducing one software which use actually the machine learning for interpretation. So seismic interpretation has become, one of the long time taking in your prospect maturation. So we'll be using machine learning algorithms for that software to interpret the seismic data. The full cube of the data. It's automatic interpretation like that. Then we have the hydrocarbon provinces again in that specific area for the case studies. And then we'll be doing the risk analysis or assessment. Then the practical group exercise will be also one of the part of this course. Then volume assessment and the volume portfolio. And the day 5, which is the last day of this course, in that we'll be having the exploration economics, because that is one of the most important. Because let's say you find the prospect but it is not economic, and you have the problem in extracting that. So we have to find out the economics of that one. Then geophysical evidences like local prospect examples. If we have some examples, we can have in the course. Then spectral analysis application, and the DHI, which is direct hydrocarbon prediction indicator. And also we look at back all the topics. So that is just a summary. I mean, that is actually in line with this. After this workshop, we'll be having this course. So let's look at this month. This is a very good figure, which I got it from American Petroleum Institute. So why we are actually exploring the oil? Because when we are talking about prospect maturation, actually we are looking at the oil and gas. So if we talk specifically about the oil, so this is a very good figure. So in that you can see here. So if let's say if we have 1 barrel of oil, which is normally equal to the 42 gallon and 158 liters. So in that, it's not only, you will be hearing that there's a replacement of the oil and gas. So that would actually bring me to show this figure, that we still have a lot of things. Like if you look at this gallon, 1 gallon or 1 barrel, sorry. So in that you have 19 gallon, which is like in 40+% of the gasoline. Then you have the fuel oil, then jet fuel. Then after that, you see like less than 50% you have other stuff, like you have the asphalt, you have kerosene, lubricant, petrochemical products, and also you have like 6.2% gallon we have other products, in which you have the detergent. It's made of this crude oil or extracted from some part of that. Then you have the fertilizer. It is used in medications, like the antiseptic stuff of the medicine, that also can be generated, that actually generated from this oil. And also we have the plastic, like synthetic fibers, the rubber, and the rust. So we have liquid petroleum gas as well. So it's not about only the using for the energy, but also we are using this oil for other purpose of in the daily life. And here, if we look at this in percentage, so this is a reflection of the previous graph, but it's showing more prominently in that part. So you can see like 43% we have the gasoline, then we have 23% heating for diesel, and 9% is this one. So still we are like 25% of the part of the oil we are using for some other stuff. So I mean, there is a lot of things like the new generation which is going away from the oil and gas. So that's one of the motivation that you can have the understanding of the oil and gas. It's not used only for the energy purpose. Obviously, this one can be again used to the recreation of the energy. So that is one of the motivation for us to learn about the oil and gas exploration. Then if you look at further what is in our daily life, so I got this figure which is very useful. So over here you can see like it can be used as lubricant, as I mentioned before. So in marine fuel we can use, but if you come down here, like here we can use the toys for the, I mean, our pets. We have the tablets, like in also it's used headphone, mobile phone, fuel. So we have a lot of application of the oil, not only the other stuff which we are thinking like pacifier. We have the rubber boards, we have these bituminous asphalt, and we have a lot of stuffs. I mean, you can have a look on this stuff in this figure. So this is actually tell us that these are the daily life. So it's about more than like 100 things we can have in our daily life. Okay, so that was about the motivation, that why we have to learn about the oil and gas. So now let's understand about the prospect, which is actually the main topic for today talk and workshop. So So what is actually the prospect in oil and gas? So if you look at the definitions or the detailed understanding of that one, so a prospect, if you look at this figure, which is a beautiful figure, so this explain that an area of exploration in which the hydrocarbon have been predicted to exist in economic quantity. So there is a lot of places we have the hydrocarbon, but the main point is that it should be economic quantity, and the prospect is commonly an anomaly such as geological structure or it's a seismic amplitude. Let's say if you have the high or the bright amplitude in the seismic, so that also can be one of the um, prospect that is recommended by the explorationist for drilling a well. So let's say in this figure, if you look at this one, so either this can be oil or gas. So this is suggested from the geophysicists or geoscientists or geologists to drill this point. So, but before that, what we have to do, how we identify this prospect. So now we have understand that what is the prospect in the oil and gas. So how we mature this, I mean, prospect, either we are maturing it or either it's already mature. So actually, if the right answer is the prospect was already mature, but actually we are trying to analyze either it's a mature or not. So that include actually a lot of stuff. If you look at this triangle, so it shows what are the steps we have to follow for maturing a prospect. So if you look at the definition or the understanding the prospect, so the process of the source rock, I mean, becoming capable of generating the oil and gas. So there is always source rock in many area, but we have to look at either it can be produced or no. Because when the exposed to the appropriate pressure and temperature, then only it can produce the oil and gas. So that is the process we have to follow. Either the prospect is mature, because if your reservoir, your source rock is there, but it is not mature, then it cannot be produced. So that's the problem. And also a source rock began to mature as it generates the hydrocarbon. So if you look at this graph, if you see, so we start from actually the basin evaluation. So we have the large magnetic surveys like the gravity survey, and also sometimes we have the seismic survey. So in regional scale, so you have to look, let's say if you are exploring in a new area, then you don't know what is the type of geology of the subsurface. So you have to come up with the gravity map or the magnetic map, or if you have the regional seismic line. So from that, you will find out either this basin, the deposition environment, and also the structure or the stratigraphy of this basin is favorable for hydrocarbon or not. Then the play evaluation. Once you have find out, okay, this basin is already mature or is capable of producing oil and gas, then you can come up to the play evaluation. So in that, what you have analysis, like you do the rock physics analysis, and then if you have the drilled well, then you can have further analysis. But if you don't have that one in data, you have like the play map or the detailed well analysis. That one also can help you to identify the play evaluation. Play evaluation, I'll explain more about the play as well in a minute. But then after we found out that there is a play in that area, then we go for the prospect evaluation. So prospect evaluation is actually is a term which we use normally for the new fields. Then we go for appraisal well. So appraisal well is the new well in the area. So in that we study the reservoir analysis and the chart, the seals, and also the petroleum system of that area. So that is also very important in that part. Okay. So let's look at, there is also some terms which we use, so we should also know that. So these two terms which is normally used in oil and gas industry, which is lead and the prospect. So what are those terms? So the prospect is, that is actually the main objective of this course. So the prospect is actually the possible deposit, petroleum deposit, where no drilling has been taken place. So it means it's a new area and there is no drilling has been done. So you are going to find the new hydrocarbons. So it's called the prospect maturation, but which has been mapped and volume calculated. I mean, in that area, let's say if you already have done the basin analysis, that's what I mentioned in the previous figure. So we have the basin evaluation has been done, play evaluation also has been done. So then you have to come up with the prospect maturation. So that's why it says prospect is something which in which the petroleum deposit has no drilling. I mean, it's a new area, but still there are some analysis has been done. But in the other hand, a lead is actually the possible petroleum traps where the available data coverage and the qualities are inadequate for mapping or delineating the rock volume. So there are also some areas, let's say, you will be hearing some news in the oil and gas or even the political news that some areas are, I mean, prospect is there, but actually the data is not enough. I mean, there is no drilling activity has been done, but it's just the rumors that you are hearing that there is a lead of the hydrocarbon. So that is actually the term differentiate between the lead and the prospect. So when we are looking at these stages of the prospect maturation, so what are the actually stages we have to follow? So the first thing is actually we have to look at the geological framework. So the geological framework of the area, let's say you have the tectonic activities, I mean, the evaluation of the area. Then you have to look at the data analysis. Like data analysis, you have like, if you don't have like seismic data or some other stuff, you can look at the regional studies. You have the gravity, magnetic maps of the area. And even if you don't have that one, based on the plate tectonic uh, activities, you can have this information, like geological information, then you integrate the data analysis. Then the third step in this prospect stage is prospect definition. So either you have to find out the prospect, which area or which formation you are looking for, because in all over the world, there are different formations. And when you have the geological information, then you can define the prospect definition, because in all over the world, the deposition of some of the um, fossils was at the same time. So it doesn't matter if you're working in Turkish basin or Malaysian basin or any other basin. So you have to know the geological information, the deposition system, then you can come up with the prospect definition. Then finally, when the prospect has been identified, then you have to do the assessment. Assessment include finding the volumes, the depth, the temperature, pressure. That is the prospect assessment. So that is actually the way forward how we can do the prospect analysis. Okay, so then after if we have the petroleum system in that area, so that is also one of the main important thing. So what are the component of the petroleum system? So we have 5 component of this petroleum system, which consist of the source rock, reservoir rock, cap and trap and migration. So all of them are very important. Obviously, if you look at the priority, I mean, what is the importance of the rock, which is the source, is very important, because if you don't have source and you have the reservoir, cape and everything, so there is no um, benefit of having this other stuff. But if you have the source and you don't have reservoir, then these are also interdependent. And if you have both source and reservoir, the cap is not there, then the oil will not stop there and it can flow to the other rocks as well. The trap is actually the feature on the geometrical figures of the rock in which the hydrocarbons. So in that case, if you look at this one, so we have, this is actually your reservoir rock, which is over here. It's organic rich, and normally it has the maximum heat and pressure. So that's why it is become the mature. So you can see here, so this rock is not actually the reservoir. This is also not reservoir, but this is actually the reservoir. But reservoir has a little bit different. I mean, you have a path to migrate. So there should be a path like this arrows can shows. So either it's a fault, it's a fractures or some other stuff. then it can migrate from this source to reservoir rock. Because you cannot produce directly from this source rock, you must need the porous or the permeable rock, which can accumulate, and also the favorable this trap. Like in this case, we have the anticline. So then, if after this reservoir rock, you must need to have the cap rock. Normally, cap rock, or you can call it like the um, impermeable rock. So it has the lower, even zero permeability of porosity, because when the oil and gas stuck here, so it cannot travel to this rock. If this rock is, I mean, the porous or something, then it can goes to this rock. So then you have the loss of this one, and then probably you have find out it's 100 barrel per day, but you will not find out that same results for that. So that is about the petroleum system. Then if you look at the other stuff of the petroleum system, so this not only the simple subsurface structure, but if you look at the prospect, so in some cases they are very complicated. So in the figure, this one is a very popular figure. So over here you can see a prospect location and the depth that has been identified as a good place to drill. It's not one place. So you can see this is a similar way. We have the source rock here. Then from here, you can see this is a fault. This is which is shows in the yellow light. So this fault behave as a migration path. So you have the source, then you have the migration path, and you have the reservoir, which is this one, and then you have the cap rock. So it's mean your petroleum system is completed. So now the producing of the hydrocarbon is here, then it goes to this reservoir rock. Then even from this reservoir rock, you cannot extract only from the this place, because you know that the gas which is normally on the top, then you have the oil, then you have the water. Yes. So let's say if you drill the well here, then you will just hit the gas, but you have to come up with this calculation that what percentage of gas you have in this reservoir. Then normally you don't extract the gas first, then first you have to extract the oil from the reservoir. So that's why you can see this one well, this is the second well here. So because the gas will have good pressure in the reservoir, so the reservoir pressure will be higher. If you extract the gas first, then the pressure of the reservoir will be a little bit low. So in that way, you will not have the maximum recovery of the oil. So if you, let's say if you hit this well for the gas, so you will just stop it at the time, or in some cases, if it's a very big reservoir, then you don't stop it, but you most of the time when you have the less oil, then you will stop it and you extract the oil first, then the gas will come up later, because the recovery of the gas is maximum rather than the oil. So let's look at here. For us to find the oil and gas, the certain condition must be met. So that was actually I have explained. So there is need to be a source for oil and gas, and the source rock should not be need to be cooked. I mean, if you have the source, then it should be cooked at a high at a right temperature and pressure. Then the reservoir should be porous and you have to be permeable. Then there is a need to be subsurface trapping, which is this one, which I mentioned here. Then there should be a seal rock, and there will be plumbing connection. And connection is this fault, which is the migration path. Okay. Now let's look at the prospect analysis. So our geological and geophysical analysis actually help us to identify and characterize the prospect in the term of critical elements. So what are those? So normally the geoscientists will work the prospect such that the volume of oil and gas that is the most likely to be present and recovered is determined. And also the range of the possible volumes is also estimated, and what is the maximum and also the minimum cases. So normally when you give a point to the drill, because as a geoscientist or a geologist, then what you have to do, you have to come up with this estimation, like what the maximum reservoir production can be, like how many billions of barrels oil you have in the reservoir. And also you have to give the chances of the success. Either if you hit the well one, then what percentage of chances you have to be successful. So that is one of the main stream of the prospect analysis. Then all this information, normally when we are working in a company, so this one you have to present it to the management, then you will come up with the budget. So now this is actually one of the fun game. So what is the prospect, how we look like? So in this, actually, I just put this example. So let's say you are a part of an exploration management team, and with 20 prospect that your staff has worked up for the approval to drill. So let's say if your staff is working and they have 20 prospect, and you have to get the approval to drill. So your prospect portfolio is rather diverse, ranging from the low risk, low reward prospect to the high risk, so high reward opportunities. Then all 20 prospects are possible oil field. So what are your challenges? So let's say if you have like drilling budget, which is 400 millions dollar, and also you have the headquarter has set, let's say your team has set a goal that you have to discover 500 million barrel of oil. And also if you want to keep the cost per barrel as low as like $1 per barrel, so that is also your own task. So what will happen, let's say if you have these targets, so either as a geoscientist or the prospect, when you are doing the prospect maturation, so you have to start from either you have been hardworking for maturing each prospect. Let's say if you have 20 prospect and you have found in one place or in one basin the 20 prospects, so either they are mature or not. And then your work for each prospect is summarized by like estimating the drilling cost. Let's say if you find this prospect in very deep region, then obviously the cost will high. If it is offshore, then it will be different cost. If it is onshore, then you have a different cost for that one. And also a prediction of the most likely amount of the oil, like in millions of the barrels. So you have to come up with that. I will also explain how you can find out the volume of this prospect. So the likely range of the possible oil volumes, like high side and also the low side of the cases, and also an estimate of the chance of success for the prospect. So that is the actually task which you have to do for the prospect maturation. So let's say if you are using your budget, so how you can spend your budget. So if you have like your seismic data, you are come up with the 20 prospect, but you have to revise your data. So let's say if you can spend some of your budget to improve the seismic data just for better prediction, because the company would not need like 20 prospect. If your one prospect is good enough and the possibility or the probability of having the success is higher, then the company will be happy for one prospect rather than they are finding the 20 prospect. So for making sure that you have to come up with this new ideas, let's say if you can spend that budget for improving the seismic, if you have the seismic data which is low resolution, so you can spend some money to reprocess it either, or you reacquire it. So that is the task you have to do. So the first thing is either you can reprocess the existing seismic data of the prospect. So let's say if 10-kilometer area you think that is a prospect, so then you will come up with a new idea, I mean new processing steps, or you go for high resolution or high I mean you can go for RTM or some other stuff, like any reprocess data, so that you can cost like 10% of the well cost, because the seismic processing will not cost a lot, because if you drill the wrong well, then you will be in trouble. So that's why your prospect need to be very mature, or you have to be very sure that this prospect is mature. Then alternately, what you can do, you can acquire a better seismic data, and the cost of acquisition and reprocessing is like 25%. If you reprocess the data, it's 10%. If you acquire another data and reprocess it, then 25% of the total cost. Then, or what you can do also, you can spend your all money on the drilling wells. So if you drill the wrong prospect, then you will be in trouble. So that's why we have to be very careful about this prospect maturation stuff. So this is actually one of the chart which shows actually the key assessment parameter. So either what are the prospect numbers, so this is like dummy numbers, then the prospect name, and we have the drilling cost, and most like volume, and the low side case and high side case, and the chance of success what we have, and the discovery. So let's say you find out like 20 prospect in any part of the basin, but you have to look at the percentage of the success. So that is this point. So if your success is higher, then you will be going for that. Obviously, if your cost is, the drilling cost is something else, I will explain on that later on. But the most important thing is success chance. So how your chance of success will be increased, then that you have the more accurate data. Let's say if you have the seismic data, you have the well information. Well information, obviously, you don't have. So that's why you are drilling it. But you can use machine learning algorithms like machine learning prediction, artificial intelligence, AI, like that stuff. So this will make your possibility of success higher for prospect maturation. So if you look at this figure, I mean, this is a very good example of prospect, how it can become mature. So probably there is many other examples that we have seen, but how does it process actually? So the source is actually over here. If you look at from source to reservoir, or extracting the oil and gas, and we get the money. So there is a very different process which is happening. So source is actually a kitchen where the organic material is cooked. So this is a very nice example. So here you can see this is a source rock. So it got the high temperature and pressure. Then from here, the hydrocarbon will produce. Then how it will travel to the reservoir rock. So there should be a migration path. So it shows in the sort of pipes, but obviously it's not like that. But it's a cartoon diagram, but it's very useful for understanding. So it's like plumbing to connect the container to the kitchen. So from kitchen to the container, which is reservoir. So that's why we need the migration path. So this guy is, I mean, connecting it. But normally in geological scenario, these are the faults or fractures or some sort of this stuff. Then it brings to the trap or the reservoir. Then it comes to the trap. And also we have the seal rock on that. So this is one of the example. Let's say if you are looking at some of these most likely scenarios, but there is also can be the different scenarios. Let's say this basin was formed in 18 million before. Then you can see this is your source rock, this is reservoir, and this is gap rock. So, but in this case, let's say if you have the oil generation source, which is this one, and normally when it's generate here, then it will also migrate to this favorable, I mean the structure. So in this case, we have the anticline type. And normally it doesn't go only here because this is seal from here, which will be left. So it will also move to this part. So let's say over here, we also have the small spill of the oils. But most likely this is, if this is the case, so it is very easy. So you can just drill a well here and you have the beta, alpha and beta well. So you can drill easily. But most of the time you have the tectonic activity, let's say in 10 million years ago. So we have the tectonic activity, because of that, this fault was produced. So in that case, your reservoir become complex. So that's why you need a better understanding of the reservoir. So in that case, similarly, we have this source rock over here, this one and this one. Then the oil generation was from here, so it goes to this part. And over here, this also behave as a seal. So the trap will be stop here. It will be trap here. Then another reservoir, you can see it can be here. And also, let's say after some time, like in present stage, so you have the oil and also you have the gas accumulation. So in that case, you have the oil, then you have the gas, then you have the oil here. But obviously, this gas was generated just in the recent time because it got mature in the recent time. So that's why we don't have any clue of the gas here in this reservoir. But in this gas reservoir, you have the gas first, then you have the oil. So that is why in some of the area or in some of the reservoir, you have or in some of the reservoir rock, you will be expecting in one point you have the oil and gas, and on 5 kilometer behind or beside that well, you will be having only gas, or either you have only gas or oil. So that is the case because this happening in the subsurface. So if you look at this, I mean the time section of this one. So this is the 18 millions year before, then this is the 10 million, and this is the present. So in that case, this reservoir contains the gas and oil, and this reservoir has only the oil. So what are the actually the exploration tasks we have to count? I mean, from identify the opportunity to the drop area, or either you have to go to drill. So normally in case of the wildcat, you have to come up with this process. So the first of thing is identify the opportunities. So if you have the opportunity, let's say on the regional studies, then you will come up with the acquisition of the seismic data. Once you have the acquisition, then you process it. Then after process, you come up with the interpretation of the data. Then from interpretation point of view, you will assess the prospect. So in prospect evaluation, as you know that you have to calculate the volume, hydrocarbon types, then you have the assessment and also the risk of this exploration. Then normally what you have after the prospect evaluation, so you will go for the drilling the well. So if let's say you are successful, then you will confirm the well. Otherwise, if you have the failure, then you will drop the area. I mean, that area will not be. But normally it doesn't happen like that, very straightforward. So you will drill multiple wells in an area to understand the subsurface structure or subsurface geology. Then only you can come up with this type of conclusion like that. Okay. So even after success, you have to do the economic factors. Let's say if you have uneconomics, then you drop the area, then otherwise you will go to the other further development of the field. So now how we can calculate this volume of the trap. So let's say this is a trap, which I have shown you in the last figure. So this is actually the cross-section view. So you have looked at this one before. So in that case, you can see how we can roughly estimate the cross-section area. So let's say if you have this area, so you can just draw the triangle. Then you have the small triangle. So based on the height and the base, simply you can come up with the volume of this. Let's say this is the height 1 per hole. Then you can minus this height 2 and the base 2 from this one. So this is just a trigonometry stuff that actually we are going to do in the course, but not exactly in the workshop. So the formula for finding this volume of a cone is 1/3 pi r square into h. So in that case, we have two cones, so we can find out the volume of the prospect. So like here, you can see this is height and this is your base. Then you can come up with this formula, and approximately you can find out the reservoir volume. So what is the volume of the reservoir? So if you look at the seismic stuff, so how does it look like? So you can see if you have the seismic, and the seismic normally you have the fluid and the water contact, which is this one. Normally this is your gas, oil, and this is water. So this line is actually explain the fluid contact, and this is the gas or oil contact. So there is also some other studies like we have to do in prospect maturation. So either we do for the quantitative analysis or the qualitative analysis. So quantitative analysis, which we are also going to do in the course in very detail. So in that, actually, the first of thing is the AVO. So either you have the different seismic lines or different seismic section. So in that, we normally divide our seismic into three angle stack, which is near, mid, and far. And actually, I will going to discuss in tomorrow workshop about the AVO, how does it work, and how we can predict the gas or the oil from the AVO analysis. So this is one of the very good technology which we use for AVO analysis to predict the reservoir, either it's a gas field or the oil field. And there is a different model response with the different rock fluid properties, which we are also going to study in the tomorrow workshop as well. And also if there should be some difference, which fluid type does it in the seismic support. So also we will be applying some attributes in the course as well. So in attribute analysis, you can also find out different type of fluid, which we are going to look at. And also some exact amplitude and the near, mid, far angle, as I mentioned, and we are going to discuss further in detail. And in qualitative analysis, what we do actually to predict the oil and gas or to mature the prospect. So in that, actually, we do the basin modeling and hydrocarbon analysis and which type of fluid we should expect. Like what did the source generated and what did the trap leak or spill. So these are the qualitative analysis from the prospect maturation point of view. So that was about the prospect maturation. So actually, I will add also some the major part of the machine learning as well. So let's look at the overview of the machine learning. So there is a different type of artificial intelligence and data science. So how we can actually merge these all together? Or if we talk about machine learning, what actually this machine learning is, and how we'll use in our prospect maturation. So if specifically I talk about machine learning, so we have the different type of algorithms. So in that we have evolutionary algorithms like reinforcement learning and neural network. So if we talk about the seismic interpretation and stuff, so we'll be using like neural network and also the evolutionary algorithms we will also use. But as linear regression, also one of the most important stuff which comes from the data science. So we will be also using some linear regression analysis and also some statistical point of view in the course to mature the prospect. And exactly if statistics and also we have the probability. So what type of probability we'll be using in the data analysis and also predicting the possibility of a successful hydrocarbon reservoir. Artificial intelligence is obviously in the knowledge modeling, the symbolic reasoning, the model that is actually we are already using. So if you look at the seismic interpretation, like in Petrel, PaleoScan software, so we are also using the artificial intelligence, like the automatic interpretation. When you give the seeder and leacher, then you can find out the interpretation stuff. So that hands-on we will do, and also we will look at deeply in that as well. Then if you look at the type of algorithms or what are the steps involved in machine learning algorithms, so we have like we have main two types, which is supervised and unsupervised. So our focus will be mainly on the supervised learning, because we are using the regression analysis and the classification of the data. So in regression analysis, in supervised learning, unsupervised is clustering, k-mean, hierarchy, and these type of algorithms. But specifically, if we talk about this course, we will not be using this one. So we'll be using more on supervised learning. So how we supervise or how we train the model, like if we have the geological model or we have this, if we have like the basin models or the prospect maturation or what type of seismic signature it has to be predict for pure prospect maturation, then we have to come up with this type of supervised learning. So that will give or take the some example from the real field, then it will include in our practical example to make our prospect more mature and more reliable. So that is actually the main objective of using the machine learning. Then how does it work? It's very simple. So we have like input layers we have in our data example. Then we have some hidden layers, which is used in the supervised learning. So hidden layers is actually the data which actually we give to the machine to predict this input data. And then finally, based on these inputs, it goes to this data analysis. Then it comes up with the final result. So in case of interpretation, so we give like the waveform, the zero crossing positive, zero crossing negative, you have the crest trough of the seismic waveform. So we come up these type of things that either the software or the algorithm has to pick peak or trough or either whatever it is. And these type of things we will also be looking at the machine learning stuff. Not only in this interpretation, but obviously if you look at the machine learning, it actually come into the every aspect of the prospect maturation. So specifically, if you look at the data acquisition and the definition of the objective, data understanding, cleanup, it doesn't come into this part. But when we bring the data from the field into the computer, so that like when we are doing the processing, so we have a lot of machine learning algorithms. So we process the data using machine learning or the artificial intelligence algorithms, like prior information it has. Then we split the data set into the training and the testing. So I mean, these data will we go for some part training and some testing. Then we build the ML model. Then coming to the training ML model. Then finally, we come to the evolutionary models, like the effective by the comparing for set of the actual values. Then what we do actually, we compare the performance of the various model, like what is the input and what was the previous information which was given to the machine to mature it or to understand it. So finally, then we'll get the selecting of the model, which is the least weight or mean absolute percentage error. So that is some we can use in processing as well. Even when we are generating like this type of near, mid, and far offset, so we can come up some of the techniques which can enhance the amplitude or this analysis of the seismic trace, which can be very beneficial for prospect maturation as well. So this is a very good and summarized table. What actually we do in artificial intelligence and what are the activities. So let's say if we're talking about the evolution of the subsurface geology. So this is in this part of we can use the interpolation techniques like non-gradient optimization and also the gradient boosting, which is very good, and deep neural network. And if because most of the part which is about the prospect maturation is comes into this part, so that's why we are using a tool like automatic mapping, as mentioned, like the rock reservoir rock over the oil field. And also there is some program for collecting the geological data from the well logs and also boosting the gradient of 100 times or more accelerated the process. So that is also one of the beneficial to predict the rock type, what type of rocks we have. Then also it can be used the artificial intelligence in drilling point of view when we are going for the drilling. So that is also one of the place which machine learning or the artificial intelligence can be suitable for that. So what are type of algorithms for machine learning is algorithm for machine learning is in combination. So different type of algorithms we can use. Reservoir engineering, like traditional reservoir simulation, can be speed up with this tool. So specifically, if we look at the algorithm or the approach, it's a deep neural network. So deep machine learning, deep learning, sorry. So we can use in that. So the production optimization, when the prospect is mature, the drilling has been done, reservoir engineers are working fine. Then the production optimization. So we have to come up with this total volume. Then based on that, the optimization of the production, as I mentioned, like how much is the gas in the reservoir, how much is the oil in gas reservoir. So then you have to come up with some probability assessment. Then you can divide either what part you have to come up with this probability assessment. So in that we have the gradient boosting, like the feature selection based on the expert opinion. So that is also one of the main use of the artificial intelligence. So this is a very good, the workflow. If we look at how we come up with this prospect maturation. So this is actually the summary of this prospect maturation. So normally we start from the global optimizer. Let's say if you have the seismic, you have the drill well, and you are doing some analysis on the basin forming. So what you have to look at, you have to come up with input data, the trends what we have. Then you come to the machine learning algorithms to predict either this stuff is like the prospect or not. Then you can come up with this prospect models. Then this actually figure shows the drill point already, but in new area, like you have to come up with the new model. Then you can suggest some of the prospect, and based on that prospect, you can come up with the drilling point. If it is a good match, then you can save the result. If not, then you can just go and repeat all these processes. So this is like reservoir modeling of the artificial neural network. Okay, with that's all. Thank you so much, and I hope